the agenda is to go through a summary of what we saw during the last session, mostly because the session was so good and so interactive that we run out of time to present the whole content that we had prepared for the first webinar. So appreciate the questions from that session. I'm seeing that some folks are again with us. I can see there Alejandro, Guida, I think it is, Kylan as well, and Rodrigo. So thank you for being here. And yeah, if you have questions, you can either drop them through the session if it's related to the topic we are discussing, or by the end of it, whenever you feel comfortable on doing it. So I'm going to try to go over this really quick. Remember that Fluent Bit and Fluent D are Cloud Native Computing Foundation graduated projects. Both of them belonged to the Fluent project. And now we are going to talk about Fluent Bit, the next generation agent, if you want. This supports logs, methods, and traces. And we are going to go over the logging challenges that we can face, right? Let me correct this here. Okay, I think it's better now. Okay, so to review this pretty quick, we need to do data analysis from our data, right? From the logs, we're going to get insights, and we are going to take decisions. During the first webinar, we did a better explanation of this topic. So if you want to review them, you can go ahead and watch the previous webinar. For now, just to keep in context of what we're doing, right? Okay. We talk about the different formats or non-formats of the logs. These are all unstructured data. So you can see the nginx access, the syslog, and the Windows event logs. All of these are not really easy to read, right? And we have many sources as well. We have many formats and many sources. Logs can come from file system, from devices, from API, from network endpoints, from our applications, etc., even from our containerization runtime. And yeah, the idea is to provide the user with better tools to do the data analysis. They don't need to get into the details on how the logs are written, what's the format in the origin of the logs, etc. We are going to simplify this for them by parsing the logs and send them out to the endpoint, to the data endpoint, right? So a lot of logs coming from different places, and we are going to simplify this for them. So we have unstructured logs, but if you have some experience in the technology realm, you may identify what is in there, right? You can get a pretty good percentage of the data there, and you can easily identify like the IP address. You can see the time that the request was sent, the HTTP method, etc. You can identify that, but not a machine, right? We need to teach the machine how to recognize this. And to do that, what we do is that we have the unstructured log. We will somehow transform it to a better version of it, right? So the machine can say, hey, this is the field IP address, this is the HTTP code, the user agent, etc. So that's what we are doing with parsing. Again, for more details on that, please go to the previous webinar. It's published online. So basically, this is what we are doing in these two sessions. We are doing parsing of this data. We are taking unstructured data that contains data that we can identify, and we need to teach the machine where is this data, right? So transforming from unstructured data to structured data. That's the parsing. And again, right? If you try to do these transformations, reading these all different sources is not an easy task. We know that, and that's why the parsing comes to the rescue, right? And the idea is that you can do processing before your logs database or log data lake, instead of just sending everything there, because most of them will charge you for the storage or directly for the transfer amount of data. So yeah, we need to do things before. Okay, this is a recap of all that. Some data on that. We can say that companies will generate between 20 and 30% more data every year. And that means that your feel for the service where your data is being stored is growing up, at least to that percentage. Unless, of course, you do some processing before sending your data to those services, which of course are good services, but you can always improve how they work, right? Okay, so in the previous webinar, we run into some examples with basic parsing. We did some parsing using a common log formats. We went over Apache common logs, and we also did a bit of Java applications, which we have seen a lot in the big cloud providers. We have seen a lot of apps running Java. Of course, not only Java, but we think is a good example. Could be also Python and Go, the ones that we can see there, but that's what we did during the previous session. Now we're going to continue with this. We're going to add some missing examples, and yeah, let's do this. So I'm going to show for context this one, which was the Apache common. For this Apache common format, we generate these samples, and we did some processing with built-in parsers. Remember that Fluent Bit ships default parsers, meaning that are parsers for common formats, and we will provide you with all these: Apache Error, Nginx, Kubernetes, JSON, etc., Docker, CRI, etc. So we have a lot of parsers there that are shipped by default with Fluent Bit and that you can use. And for this example, we use the Apache parser, which is defined here. So with that, we can run that configuration. There's the Apache. Right, and this will parse this data here. So you can see this is the host, right? Then the user, the method here, the path that was in the request, the HTTP error you can see here, and the size of the request, and the timestamp. We can also grab it and send it. It's not being sent in this one. But what happens? Let me go to the configuration, because this is quite simple, right? We have the Apache log file, and we have this one parser. Okay, but what if my application, my Apache server, is now running in a CRI container? You know that CRI will have another format, right? So it will prefix every log record with, sorry, my kitten is around here. So it will prefix every log record with some extra data, right? Let me open, okay. So basically what the CRI will do is to add a little bit more context to this. For example, this record will be transformed into something like this. So it will add the timestamp at the beginning, then where's this data being written to, and the stream as well. So what if I'm with this case? Should I just chain these filters? Should I do further processing? Okay, let's go to that. As you may know, in the tail plugin, you can have not only one parser, but several of them. For example, here we could have CRI, Docker, Java, Go, Python, etc. Per definition, what the tail plugin will do is to try to match the event record or the log event with one of these parsers. But if, for example, you have a Java application running on CRI, this will not be enough, because the Fluent Bit engine will do the match with CRI, but it will not try the rest of parsers here. Okay, so that's a clarification, because we have seen questions about that. We have seen configurations where users expect to have this and to have Java records parsed from the Java records from applications running in CRI runtime to be parsed automatically. Yeah, that's not possible. So remember that you can have a list of parsers here, but think of it as a list split by OR operators, right? So it will be only one of those, okay? So on this case, we have Apache, right? And this is working. But what happened if instead of that, we have the CRI? Let's simulate this. So we are going to use the log samples Apache common. Okay, so we have prefixed these records from the Apache common log with the CRI prefix, right? This is what CRI will add to that. When Fluent Bit goes to read the log file, it will see this instead of only what we have above here. So let's add the Apache common CRI log here. Right, and coming. Well, close enough, but yeah, of course, if you know me, you know I'm going to fix that. Okay. Okay, so let's see what happens when we run the same configuration against this. Okay, so we should expect to see this correct processing, right? That we see if we only have Apache common log format. But let's see what happens when we try to process these log records coming from or being written in CRI. CRI. Okay, so what happened is that Fluent Bit doesn't know how to parse this, right? It knows that inside the message, there is a format that should match with this regular expression, right? Where we expect in the first place the host or the IP address, right? And then user, etc. So, but now, because we are running this application in CRI, we need to do, first of all, we need to split this data, right? We need to extract the CRI part. So for that, we're going here and we will say the parser will be CRI because this application is running in a CRI environment, right? Okay, so let's run this. And okay, there is something different now, right? Let me expand this a bit and we'll compare two of them. So the previous one, we can see that the only field in the record is the log field, right? That's the only one that we got because Fluent Bit couldn't match it to any regular expression in the parsers defined, which is only one for this case. So that's what Fluent Bit captured. It captured the whole content and put it into the log key, which is the default key for the log. But when we run the CRI, we were able to actually capture the time, the stream, right? The time, the stream, and the tag, right? And then the rest of it is the message part for Fluent Bit. So now that we have cleared out the prefix that CRI adds, now we're going to process the record using the Apache Common filter. So we're going to add filters here. We're going to add, parser, Apache, and key name is message. This is message. It's not log as before. Here it was log, now it's message because of the parser, right? Show you. Okay, so now we are going to process the same records, but are going to extract these fields from the CRI format, right? And then to capture the rest of the record. So let's run that again. Okay, so now we were able to go in a way back to what we had before, right? Let's say that we were running Apache in a VPS or in a physical machine, whatever. And then we had to move it to CRI and the parser stopped working, right? Because Fluent Bit didn't know that the log was now coming from a CRI environment. So we need to tell Fluent Bit that before applying the parts that we define for this, we need to get rid of the CRI part of it. Sorry, I just noticed that I lost my camera and that was my kitten. So give me a second, please. Okay, sorry. She decided to take a nap on top of the USB hub, so that's why I was losing the camera. Sorry for that. Okay, so I was saying, yeah, we were running in a different environment, in a VM or machine, and the format was one. But then when we move our Apache to CRI environment, we now have this that is added by the CRI runtime. The same will happen if you run it in a Docker container. Docker will also add the prefix to that, and then add the log record from the application. Okay. So recapping this, if you have the need to apply more than one parser, you have to chain them, right? You need to apply one parser first and then the next one. And then the rest of your pipeline can continue as it was before. Okay, any questions so far? It seems we don't have any. Okay, good. So another part that I would like to bring is the nested exceptions that we saw, and a bit more clarification on the multiline parsers. Okay, remember that multiline parser, there are two in Fluent Bit. There is one that will use the first line parameter, and then there is the new one, which we recommend to use, that need to configure the multiline.parser, right? And these are parsers that you will define. Okay, let's see how these parsers are defined. This multiline parser is basically a state machine, right? The only required state that we need is the start state. The rest of the states, you can name them as you want. For example, here the original parser was something like this, to capture the first line of a multi-line message. This is the first rule that you must define, how to capture the first line. Similar to the first line from the previous one, but the difference is that you will define that regular expression, and then every continuation of the multi-line parser. Okay, so in this case, this was the first Java that worked in most of the cases, but then we noticed that it wasn't parsing the nested exceptions. So we had to add this nested status. Okay, this state here and this transition to this. Basically, what you are saying to the engine is, when you see a match with this regular expression, then move to this state, right? Sorry, again. When you have a match with this regular expression, move from any of these states to this state. That's what's going to happen. And that's how the engine will know that it continues inside a multi-line record. So again, you are on this state. And if you have a match with this regular expression, you will move to this next state. So what happens if I have a new format, if there is a change in the format that my application is writing logs? For example, this one, which is from the Spring Boot framework, well-known Java development framework that added an empty line, right? And we received some reports from users that, yeah, the built-in Java parser was not working, was not capturing the multi-line records. And yeah, it makes sense, right? Because after the exception part, after the exception part with colon, right, we were expecting different text to come. That we were expecting some stuff there, right? Either another exception or some line saying nested section or etc., right? So if we run this configuration, this multi-line configuration, let's run it with Java Nest first. Yeah. If we run this configuration against the well-known Java multi-line format, multi-line nest not registered. Multi-line parsers. Okay. Okay, so if we run it to the well-known format, this is going to work, right? This is the records that we are parsing here. So there is an exception, and then the stack trace here, and then the cost by, another segment of the stack trace, right? So this is well known. It knows that there is a nest exception, right? So it's able to capture that as part of the main exception. So yeah, that works. But what happened now when I have an empty line here? Let's take a look. So instead of Java Nest, we're going to run it with the Spring Up. Sorry. Spring Up log. Okay, this doesn't look good, right? We have, for once, we have this banner here, but also we were not able to capture the multi-line. This doesn't. Yeah, it's not this one. Spring Up. That's the one. Okay. So this is multi-line. Okay, this is multi-line, but as you can see, there is one record here that should be the same with this one, right? Let's go back to the log here. this this patcher servlet, right? This should have the exception here below, right? This is only one exception, should not be split, right? Should be only one multi-line exception record there. But as we can see, is more than one. This is part of the runtime exception as well. So for that, we're going to use the first parser as a base, and we're going to add this empty line state, right? So we can detect when we are in the Java after exception status. If we detect an empty line, we're going to move to this next state, the Java empty lines state. And if we are here and we see an exception, right, or error or trouble, we will go again to the Java after exception. So it means that we will enter the multi-line record. We will see that the empty line can be part of the multi-line record, and then bring it back when we see the exception, right? So instead of moving to a different log event, we know that we are still inside a multi-line because of that, because the empty line is part of it or can be part of it. So we're going to change the parser that we have to the multi-line with empty line. Let's see. Okay, so now we have here that this Java empty line, right? Now it is part of this multi-line record. Now the multi-line engine was able to identify it because we told them that if you find an empty line, that could be part of the multi-line log event. Okay. So any questions? No, it seems no questions. Okay. So a couple of recommendations. Those were the demos I left out from the previous webinar. So that's what I wanted you to show. If you have any issues with multi-line parsers, we can take a look, because we have a few minutes for that, I think. Recommendations, have a process, right? We have recommended during the past webinar to use the tooling that is out there. If you are not well versed in regular expressions, use Ruler, use AI to write your regular expression, bring up a small test lab that's quite easy. As we saw in the examples, this is only pretty simple configuration. Just make sure that you're always reading from head, and the refresh interval and the flash are set to low values, and you can start doing your parsers for your logs, for your different logs. If you need help, we are here for you. We have a community Slack where some teammates are answering questions. We also have the GitHub repo, etc. But for that case, when you need help, make sure you have a repro. This is a very common error, I would say, when we are looking for help, that we cannot easily show the issue to the person that could help us. If you have an issue, make sure that you have the steps to reproduce that you have samples of the records you are trying to parse, and that you provide the environment information. There are some special cases where the operating system should come into the picture and should be relevant for that. In most of them, no, but information like your full configuration or your repro case configuration where you isolated the issue, your versions of Fluent Bit, mostly important, provide that information. Make sure that if someone sees it, that person will be able to see the issue that you are seeing, that you took the time to reproduce the issue in a way to simplify the life of that one that is going to help you, right? Please don't be these users that say the parser is not working. Don't do that, because I think you will not help someone with that vague question. And remember that this is open source, so it's for most of the people there, it's free time that they are putting into this. Okay, so have a good repro. The minimal required config. You don't need to share PII in the sample, right? You don't need to share the IP addresses of the host where you're sending the data. You don't need to share passwords. No. Delete all that data and provide a good repro that anyone can reproduce, right? And again, we are at GitHub, Slack, and Stack Overflow.